ahead and take it away. Hopefully everybody can see your screen.
Okay, great. Thank you, Doug.
Thank you.
Good day, everybody. As Doug mentioned, I'm Justin Glisson, State Climatologist of Iowa for the Iowa Department of Agriculture and Land Stewardship. And it's my pleasure to give the North Central U.S. Climate and Drought Outlook for the month of November. This is my second go around, so here we go. General information here. This is one of the things that is great about these presentations and about the group is that this is a collaborative effort between state climatologists, NOAA, federal, state, local entities, MR Midwest Climate Hub, all these different organizations that pack information into these presentations. So it's a collaborative effort and we do a great job. The next Climate and Drought Outlook webinar will be held on December 17th at 1 p.m. Central Standard. And it is from my colleague, Dr. Beth Hall, the state climatologist of Indiana. So here, the links below will give you past recordings and all kinds of other information. And as Doug mentioned, questions at the end. So for the presentation outline, what we'll look at is our recent conditions that we've seen across the North Central region, temperature and precipitation ranks for the month of October, but also looking at 30-day temperature and precipitation departures to kind of give us an idea what conditions are like on the ground, and then how are they impacting wetness and dryness across the region, especially drought. We'll look at some growing season progress as harvest has completed or near completion across much of the states that make up the central region. Then we'll talk a little bit about a gamut of things, snow, fire, rivers, and lakes, impacts and notable events that have occurred over the last 30 days. And then we'll get into those outlooks, La Niña, short-term outlooks into December, and then actually looking at December and then seasonally. And the picture on the right here is the Capitol Complex in Des Moines where my office is. This was the October 19th snow squall that I'll talk about later that we had across central Iowa. Okay, so recent conditions. The first plot we're looking at here is the October temperature ranks. This is a statewide average temperature for each of the states. And the bluer the color, that means we're below average, or the deeper the blue, the much more below average we are. On the flip side of that, the warmer or redder the color, the more above average the temperatures were. Well, as you can see, the period of record here is 1895 to the present. We had blue across the region. Top 10 coldest Octobers for the Dakotas, Minnesota, Wisconsin, and the state of Iowa. And this is generally because of the weather pattern that we saw during the last half of October. You look around the periphery, you see those reds. We had that dip in the jet stream that brought colder air down to the central United States. Hence, we were colder than average across the board. Wherever you see white, pretty much right in the middle of the distribution or average. If we look at year-to-date temperature ranks since January, what we see is that we've actually been above average temperature rise-wise across the United States, including the Central Division. So we've seen the ranks anywhere from top 30, going back 126 years. I'll draw your attention just for a note of Florida, Arizona, and New Mexico. Wherever you see 126, that has been the warmest on record. We didn't get those values in the central United States, but pretty warm conditions for many of the states in our region. Additionally, we'll look at the precipitation ranks. These are the same as the temperature, but of course for precipitation, anywhere where you see those green colors, above average precipitation. Anywhere where you see brown colors or those darker colors, below average precipitation. And we define precipitation as anything made of water that falls from the sky. Snow, freezing rain, sleet, and rain, all the liquid equivalent. You add that up and get the average. What we see across much of the central region is drier than normal conditions or near average conditions where you see those whites. Now we look at Montana, 116th, so a top 10, 11th wettest October on record. But generally across the United States, the eastern part of the central region, wetter than normal. But again, generally in the middle of the United States, near normal to slightly below average. Looking at those year-to-date ranks, quite the split across the United States. You divide the United States in half along the Mississippi River. Anywhere effectively east of there, we have wetter than normal conditions, some record-setting levels of wetness. Then you look west, 25th driest year to date for the state of Iowa, 36 for Minnesota. So yes, getting into the Dakotas, even drier. So we have seen a dry pattern set in across parts of the United States, and again, quite the flip of the coin when you look at east to west here. So now what we're going to look at are departure plots, and these, a departure means how much above or below average we are, and these are for the last 30 days. The plot you're looking at here is the temperature plot. So wherever you see those greens or those cooler colors, that's where we've been below average temperature-wise. Wherever you see the warmer colors, that's where we've been above average. What we can see across the central region is the story has been colder than average temperatures over the last 30 days. And these colder temperatures really have impacted some sorts of behavior, especially precipitation. Now, we mentioned that we've been drier than normal year to date and in October for some of the region. Well, having dry conditions, and this is the percent of normal precipitation. So wherever you see, again, those warmer colors, that's where we're below average, percentile-wise. Colder colors, above average. What you can see here is there's an axis of a very interesting behavior from eastern Colorado all the way through Kansas, northern Missouri, Illinois, into Indiana and parts of Michigan. We've seen a split in the storm track, a lot of activity south of that line, and where we see these warmer colors is where we've had a lack of precipitation. Now, lack of precipitation over the last 30 days has impacted agriculture, in which we've been able to have a pretty fast harvest across much of the central region. But what this also does is it gets into moisture recharge for the subsoil, getting into next growing season. And combine these with drought conditions, we have seen dry conditions perpetually across parts of the central region, with our driest behavior across North Dakota into Minnesota. And then again, that axis from Colorado through Michigan. It also expands into Canada, so it's a pretty good stretch of below average precipitation. So combined with looking at that below average precipitation, this product here is satellite indicated subsoil moisture down to 200 centimeters, or about 40 inches, I believe. Again, there are shortcomings with our soil moisture monitoring systems. Satellites have a hard time penetrating down, deep down. We also have modeled products. You see on the nightly news the forecast for the atmosphere, highs and lows, things of that nature. We also have land surface models that do the same thing for subsoil moisture. The story here is that where you see those red colors, that's where we're percentile-wise below average, in some cases much below average. If you think of the subsoil as a sponge, wherever you see those darkest red colors, that's the second percentile. What that means is there's 98% of that sponge available for moisture infiltration. So very dry conditions. These dry conditions go along that axis of dryness that we saw in the precipitation fields, and especially in the drought region, western Iowa, getting into Nebraska, northern Missouri, and into the Dakotas. We're seeing similar signals in our moisture fields that are telling us that yes, we are dry, and we're getting drier in parts of the central region given the lack of precipitation that we've seen. On the flip side, look across the mid-Atlantic states, lots of greens and blues there. We've had a lot of tropical behavior, a lot of tropical activity, so that's where we've seen a good majority of the precipitation falling over the last few months. Now, if we look at this USDA product from the USDA NASS, which is the Agricultural Statistics Service here, this tells us how dry or how wet the subsoil is. This is percent short to very short, so this is the dry side of that. The top number for each state is the percent of topsoil that's short to very short, meaning dryness. The bottom number in that bracket is the change from last year. What you can see here is wherever you see those darker browns, that's where we've seen an increase in the amount of dryness in the topsoil. What we see across the United States is wherever you see those browns, pretty dry topsoil. And this is an indicator of lack of precipitation and also with that subsoil moisture that we're seeing. Given the windy conditions that we've seen recently, there's a lot of evaporative demand that develops in the atmosphere, so you're able to evaporate that soil moisture and get it into the atmosphere, and hence you're seeing a wide-scale drying across the region. So we kind of started to mention drought here. This is the current drought map issued this morning and backdated to the previous Tuesday for the central region. Of note here is Colorado has been in perpetual dryness for a few years here. So we see that D3, D4 extreme to exceptional drought in Colorado. You move further east, there is a small D3 extreme drought core across northwestern Iowa getting into South Dakota. That's actually the second D3 region that we've seen across the state of Iowa, the first of which developed across west central Iowa, which really started to seed regional drought conditions. We see it expand through the late summer into fall across the region. Wherever you see yellow on here, that's D0, that's abnormal dryness. That is not considered drought, but it's telling us that conditions are as such that drought can form if precipitation patterns do not kick back in. So again, pretty much a lot of the region, anywhere from, let's say 70% of the region has some sort of abnormal dryness or drought. A better way of looking at this, or a more instructive way of looking at the drought categories, is the change map. So this is a change from a previous month, so October 20th to November 17th. And what you see here, wherever you see green, that's where we've seen improvement across a given state or a given region. Wherever you see those warmer colors, those are degradations or an increase in drought conditions. We see a bullseye in the middle of Iowa, but also in southwestern Missouri, where we've seen 2 to 3 category improvements given the wet conditions that set in just over the last 30 days. The storm track, where we see the transient low pressure systems moving, has been locked in over that part of Missouri, and we have seen improvement across southern Illinois into Indiana as well. And then smashed in between those two regions of improvement is again that swath from Colorado up into Michigan, where we've seen drier than normal conditions, and as such it's reflected in a 1-class degradation in the drought map over the last month. Okay, so now what we'll look at is growing season progress. We'll look at our row crops, some of our other crops that are grown, wheat, sorghum, and we'll get an indication of just how harvest has progressed this growing season. So the first thing we'll look at are corn and soybeans, percent harvested. Again, the number on the top is the percent harvested for the state. The number on the bottom is the change from the 5-year average. Across the board, with the exception of Ohio and Kentucky, corn progress has been pretty exceptional. Almost all harvested across the central region, 97% in Iowa, go up to North Dakota, 97%, plus 27% of the 5-year average. So really rolling, combines are in the fields. And this is a reflection of the drier than normal pattern that we've seen across the central region. If we look at soybeans, you have a lot of states in there from the Dakotas over into Minnesota that have completed harvest. So harvest has been ahead of schedule. Only Ohio and Kentucky, again, given the wet conditions that we've seen, we have a slight decrease in the amount harvested from the 5-year average. But overall, the numbers look pretty good. And these figure credits are from Brad Rippey from USDA, Office of the Chief Economist, and this is the Agricultural Statistics Services data. So then we'll look at some specialty crops, sorghum and sunflowers. Sorghum from South Dakota down to Texas, you've got that band, pretty good amount of harvest. Oklahoma recently had an ice storm, been wetter than normal conditions, so we have seen a decrease from the 5-year average. Sunflowers in the Dakotas and then Kansas and Colorado ahead of schedule. So overall, we've seen very good progress in the fields, and that's a function again of the wetter or the drier conditions that we've seen, but also warmer conditions that we've seen given the periodicity and the variability of the air masses that we've seen just over the last 30 days. And I'll get into that a little later. Winter wheat progress. Again, we have some the top left here is percent planted. Wherever you see those white, it's 100% planted. Anywhere else, greens, ahead of schedule, and then you get into outside of our region, we have some behind. Winter wheat progress, the percent emerged. Given the conditions that we've seen across the upper Midwest, we have actually seen a slight behind average in the Dakotas, and then right near average for Kansas, getting into Missouri, Illinois, Indiana, and Ohio and Michigan. So again, with the row crops and our other specialty crops, winter wheat is looking good in terms of being planted and in some states where it's emerging. Okay, so switching topics from agriculture to more of hydrologics and where we are for the month of November. First thing we'll look at is modeled snow water equivalent. So snow water equivalent is if you took the snowpack on the ground and you melted it, how much water would you get out of it? Wherever you see gray shading on here, there is either a trace to 1 inch, or we can't necessarily make an estimate on what we're seeing. What this is telling us, though, is that we don't have an expectation to have a lot of snow on the ground as of now. And given the warm conditions that we've seen recently, any snow that would have fallen in the upper Midwest probably would have melted. Look at Colorado up into Wyoming. You see snowpack is starting to form on the mountains as we would expect. So the next iteration of this presentation in December, we'll start to see an increase in snowpack. Now we'll look at the current snow water equivalent. So the same idea, but percent of normal. So what we would expect and what is actually on the ground. Within the ellipse here, you see smaller basins that make up the water system across the western United States. Anywhere where you see that dark blue, those basins have seen upwards of 150 to 250% of above normal snow water equivalent. Wherever you see the warmer colors, that's where we're seeing the basins having less snow water equivalent given percent of normal. So this is a plot that we will watch as we get into the winter season, and we'll see how these numbers stack up, because this will give us an idea of moving into springtime, the amount of runoff that we can get from a melting event from the snowpack itself. So this will give us an idea of potential flooding impacts, but also larger scale hydrological impacts.
And Justin, just one more thing.
Yes.
You go back. So don't get too hung up on these numbers. It's very early in the season for snow accumulation and snow water equivalent. That said, as you're going to see from a number of the outlooks, the areas to the north are going to be predicted to be wetter than the areas to the south. In fact, it's going to be, leaning wet to the north and leaning dry to the south as we go, as far as the outlooks go. Anyway, go ahead, Justin. Sorry.
Thanks, Doug. Yep. No, thank you. Okay, so now what we'll look at is the significant wildland fire potential outlook for November. wherever you see red on there, that's above normal potential for fires. And we have seen historic fires across California, but also in October, across where you see that red ellipse, that was effectively filled in with red. So we've had a significant reduction of potential fire from last month. But again, this is expected given cooler and wetter conditions developing. But as I mentioned, most of the areas within that red ellipse had above normal potential. We'll get into Colorado in future slides, but they had three record wildfires across the state in October and September and October, which are still burning but have been somewhat contained. Okay, now we'll look at the Missouri River main stem reservoir status. So this is the storage in the Missouri Basin. And currently, system storage is at 56.7 million acre feet. Looking at Gavin's Point Dam, which is the gateway into the southern part of the basin, we'll see reductions in winter release that are scheduled for November 24th. Currently, Gavin's Point is releasing 34,000 cubic feet per second. And these releases will be adjusted given the navigation targets that are necessary this time of year. If you look on the right-hand side here, this is the system storage comparison. Where you see that arrow that says we are here, that is the current part or the current point in November. You can see that we're between the average, or we're above the 1967 to 2019 average and below the maximum. So right within where we would expect. We're slightly above average, but not so much that there would be any concern in terms of where we are right now. For comparison, you look at 2019 and 2011, those were record storage years. So we did see flooding within the basin in both of those years. So that's what we use for historical comparison. 28-day average stream flow. Stream flow is the amount of water within the stream system. Wherever you see green or colder colors, that's where we're above normal in terms of the amount of water in the stream system. Wherever you see those warmer colors, that's where we're below average. And those are an indication of where precipitation has not fallen or drought conditions have been existent. So we look at central Illinois into northern Indiana, also the Des Moines Basin within the central part of Iowa. We do see some much below to low stream flows. We have some restricted flows currently in place given the drier conditions that we've seen across the state. Then you look at the desert Southwest, again, showing us another indication of the dryness that we've seen. Indications both subsoil moisture, drought conditions, lack of precipitation, all those again feed into the wildfire outlooks or the wildfire behavior that we've seen. So yes, all of these indications give us an idea of what the conditions are on the ground, but also where we can expect drought formation to continue or where we've been extremely wet. And as I mentioned, with the tropical storm track being locked in over the mid-Atlantic states, you see much above to high as a flip to the dryness across western United States. Okay, now we'll look at the Great Lakes water levels. So 2018, 2019, we saw record levels on all of the Great Lakes. This plot is for Lake Superior, and this is from the gauge at Marquette in Michigan. The record high is that teal color line box, and then you have the current gauge reading. So we're still above the long-term average, but we're below the record levels that we saw in recent years. And in terms of forecast, the forecasted levels over the next 6 months should remain above the long-term average. So it's just something that we've seen within the system, and this is pretty reflective of the other Great Lakes. Okay, so now we'll talk about impacts and notable events that we've seen over the last 30 days. State impacts, there was a big snow event at the end of October in Colorado, which helped contain the widespread and historic fires there. The state had never seen a 150,000 acre fire, and since September they have had two. The Cameron Peak fire, which you see here looking from Estes Park, and the Pine Gulch fire. So two massive fires that set state records for Colorado. Some other state impacts. We've had some pretty variable systems come through the upper Midwest, going from pretty warm conditions to pretty cold conditions within a few days. As such, we had hundreds of waterfowl killed across northwestern Iowa due to a rapid change in weather patterns. And these are migratory birds that were flying south overnight. They like to rest, and there was lots of standing water on some roadways up in northwestern Iowa. The ducks and geese thought this was lakes, landed in that water, and were disoriented. 200 to 300 were killed by cars or from actually hitting the surface thinking it was a lake. Along with this, we had a record-setting October snowstorm in Minnesota that dumped some heavy snow. We also saw heavy snow in northern Wisconsin and in the eastern Dakotas. We saw slippery conditions, that heavy wet snow, all those problems that go along with that heavy wet snow. And then, as I mentioned earlier, we had a snow squall across the Des Moines metro area on October 19th. It was the first snow squall warning that was issued for Des Moines on record. And just to give you an idea what a snow squall is, we can think of a concentrated blizzard, but without the wind. You have snow falling at a rapid rate, reduces visibility, and is able to eventually stick to roadways, and you get lots of car accidents and traffic concerns. Anywhere from 5 to 7 inches within central Iowa that fell over 2 to 3 hours. As I mentioned, we have our moisture fields, our subsoil moisture, and our stream flows. They're pointing to dryness concerns. Subsoil conditions across much of the region show below normal percentiles. If you think back to that percentile map, wherever you saw those reds, that's where we're below normal. Recent warm and windy days produce higher evaporative demand in the atmosphere. So the atmosphere gets thirsty, and especially for this time of year, those conditions allow for extraction of any subsoil moisture or surface moisture that we see. With lack of precipitation, this makes soil or rainfall infiltration, when we do get it, harder to get down deep. It stays on the surface. So that's where it's easy to evaporate given these warm and windy conditions. Dry soils will freeze faster when the temperatures, of course, get below freezing. When you have a deeper freeze level, that inhibits the amount of infiltration of any kind of moisture. What we're getting at here is that subsoil recharge for those drier parts of the central region are of concern for next growing season. So we do need to have subsoil moisture for our row crops and for our agricultural products to actually live and thrive off of. Now, the silver lining here is that moving into the growing season, drier than normal conditions will make field work and planting easier. If you go back the last 2 or 3 years, we've had pretty wet conditions going into the growing season with record subsoil moisture, which delayed planting, delayed field work. So again, we do look for silver linings here, and having drier conditions do bode well for field work. And just to give you an idea of when we would expect a good amount of rainfall to recharge that subsoil profile, going back to the beginning of meteorological fall, September, October, and then to November 19th, we've seen this similar plot before, but anywhere where you see those warm colors, that's where we're below average percentile, or as a percentage of what we expect. Only eastern Iowa and into southwestern Wisconsin and Illinois, and then over into Ohio and Kentucky have we seen above average precipitation for the season. So this really does point to dry conditions, and again, those concerns for subsoil recharge when we're expecting precipitation. As I alluded to, we've had pretty windy conditions. If you look on the left-hand side here, this is the monthly mean 10-meter wind speed. So meteorologically, we take wind speed at about 30 feet. The interesting thing here is that we see a band of 5 to 6 meters per second from Texas all the way up through Iowa into Wisconsin, the northern part of Illinois. So we have seen windier conditions. My friend and colleague Trent Ford, state climatologist of Illinois, sent the plot over on the right-hand side here from the National Weather Service in Chicago, showing just how windy it has been at Chicago O'Hare. This is from October 12th through November 15th, so a 35-day period. But this year, wind speeds of anywhere from 30 to 50 miles per hour. We've seen an increase in 57% on those 30 mile per hour wind speeds, and then a 9% increase on those really gusty 50 mile per hour winds. So yes, indeed, we have seen very windy conditions across much of the central region. So a few more slides here of interest. This was the end of October, October 19th through the 31st. Wherever you see those really blue colors, that's where we were below average temperature-wise for this time of year. So we had a system set up, a large-scale atmospheric system set up, where we had a plunge in the jet stream, and we had colder air masses coming down into the middle of the United States. And then on the coast, you see above average temperatures. During that period, from the 18th to the 24th, anywhere where you see dots on this map are where daily low temperature records were broken or tied for the given dates. So wherever you see the black box there, the black square, both low minimum and maximum temperatures were broken. So a widespread swath of daily temperature records broken. And then we get into the first part of November. We see a flip in the circulation pattern, the large-scale atmospheric circulation, and we see temperatures anywhere from 19 to 25 degrees above average, just within a span of a week or two. So a shift in 50 degrees of warmer conditions, and these were coupled again with those windy conditions. We see a lot of daily high temperature records broken or tied, and this was between the beginning of November all the way through the 18th. Everywhere you see a dot there, some record was broken for a date. Number of high maximum temperature records broken above 1,300, and then the high mins, so the high minimum temperatures overnight, over almost 700. So quite the shift from cold temperatures to warm temperatures and those records that were broken. Finally, station extremes. This I found, this was from Brad Rippey. There were some stations across the central region that saw record monthly lows in late October, but also monthly record highs in early November, given the circulation pattern that I just saw you. One example here is Scotts Bluff, Nebraska. October record low of negative 10 degrees on the 27th, and then getting into November, record tying high of 80 degrees on the 3rd, followed by the same temperature on the 4th, and then 81 degrees on the 5th. So it's fascinating how you can see a shift in temperature over a pretty short span of days and weeks. Okay, finally, we'll get into climate outlooks. We'll look at the La Niña Advisory, our 7-day precipitation forecast. Hazards, we don't have any. I didn't remove that. Then we'll look at some short-term outlooks. And then finally, the monthly and the seasonal precipitation and temperature outlooks. So we are currently in a La Niña advisory, meaning that La Niña is currently in phase. In October, the tropical Pacific atmosphere, think of the oceanic basin and the atmosphere both indicated a strengthening of La Niña. So for a La Niña or an El Nino phase to occur, you have to have the ocean couple with the atmosphere, and we see that happening right now. La Niña is likely to continue across the northern hemisphere into winter 2021. There's a 95% chance during January through March and into spring of 2021. And then if we look past spring, 65% of La Niña still being in phase. And at negative 1.3 degrees Fahrenheit, or I believe it's Celsius, this was the 8th strongest negative October value on record, and records go back to 1950. So let's look at this plot. The plot you're looking at is centered on the Pacific Oceanic Basin. Wherever you see those blue colors, that's where we see sea surface temperatures below average. Around that, you see those red colors where we have above average. When La Niña and the sea surface temperature anomalies take hold in the tropical Pacific, it shifts thunderstorm activity further west in the basin. And as such, it impacts the path of the storm track and the jet stream across the United States. We call it a teleconnection, meaning that weather is impacted by behavior far, far away. So a very interesting thing to study. If we look at analog years or years in which we've seen strong El Niños, this plot shows you the 20 strongest La Niña events since 1950. Wherever you see blue on this plot, that's where temperatures were below average. Wherever you see red, that's where temperatures were above average. As you can see with the top 20 strongest La Niñas, it kind of runs the gamut on the temperature behavior, with a specific region where we do see a consistent behavior of colder than average temperatures, and that's the upper Midwest in the Dakotas over into Montana. Looking at La Niña versus El Nino phase, we do see a lot more variability in the La Niña behavior than we do in El Nino, for example. If we look at the precipitation side of La Niña, strong La Niña events since 1950, you do also see a lot of variability. There is a pattern, a normal pattern that we see on several of these analog years in which we see an above average precipitation signal over the Ohio Valley, and then also up in the Pacific Northwest. But looking at all 20 in general, we do see a lot of variability. So this does give us pause in terms of the predictability of behavior, but we'll look at that in the outlooks. So as I mentioned, and we can skip this one, those blue bars, the higher that blue bar is, the higher the probability of La Niña staying with us. And as you can see, moving into February, March, April, we're still between 80 and 90%. So this does give us pretty good guidance that La Niña is sticking around into springtime. Finally, we'll look at the 7-day, what we call quantitative precipitation forecast. This is the amount of rainfall or snowfall or precipitation in general that you see on the news in the morning or at night. We just sum it up over the next 7 days. Wherever you see those purple colors, that's where you see the probabilities or the chance of having anywhere from 2 to 3 plus inches, specifically over Missouri, southern Illinois into Indiana. And then smaller amounts moving north into the central region, with the expectation of anywhere from 1/10 of an inch in Minnesota down to 3/4 of an inch to an inch southern Iowa. So yes, we do see where the storm track is locked in, and that's where we're seeing the forecasted chances of much higher precipitation values. If we look at the short-term outlooks, 8 to 14 day, this is temperature on the left, precipitation on the right. This is for November 26th through December 2nd. What we're seeing here on the temperature side, anywhere where you see darker reds, that's where we have a higher probability of temperatures being warmer than average. Now, this doesn't tell us that temperatures are going to be 10 degrees above average, but what we're seeing here is a high confidence that we are going to see warmer than average temperatures across the entire central region and much of the United States. If we look at the precipitation side of it, anywhere where you see those darker browns, that's where we have higher probabilities of drier than normal conditions. Again, this is good for getting harvest complete, not so good for soil recharge moving into winter when the soils will start to freeze. Finally, the December outlooks, which were just issued this morning, we are seeing again a classic La Niña signature in temperature where you see higher probabilities of colder than average temperatures in the Pacific Northwest and along the Alaskan Panhandle. Precipitation side, we see that higher or elevated shot of wetter than normal conditions across the Ohio Valley, and then again into Montana and the Pacific Northwest. For much of the central region, we have that EC, which is equal chance of above, below, or near average behavior, with a slight bias of 34% towards climatological behavior for December. If we look at the December, January, February, the meteorological winter outlooks, similar behavior, pretty much a classic La Niña signature. Wherever you see blue, colder than average temperatures, probability there. And then across the upper Midwest into the Ohio Valley, again, that higher or elevated shot at wetter than normal conditions. Finally, March, April, May, getting into spring, we see that La Niña signature perpetuating. So it's pretty locked into place. So La Niña, when we do have a phase of La Niña or El Nino, this does give us pretty good guidance in terms of our short-term outlooks, but also moving into the seasonal outlooks as well. With the seasonal drought outlook that was issued this morning as well, wherever you see brown on this map is where we see drought persisting. So western Iowa, much of Nebraska, North Dakota, into Colorado, and then west of that, we see drought removal likely. And that's where we see this El Nino signature of elevated probabilities of wetter conditions taking hold. Finally, the outlook summary. Short-term outlooks show high probabilities of above average temperatures and below average precipitation for much of the central region. The classic La Niña signal is showing up in the updated monthly and seasonal outlooks. Given that the strength of La Niña that's forecasted, we shouldn't expect major changes in the maps moving forward as we saw in those iterations. Analog years show high variability in temperature and precipitation, especially versus El Nino years, but also those ENSO neutral where there is no phase. And some of the biggest signals for La Niña will be late winter and early spring, and you see these popping up across the Ohio Valley in the Great Lakes where we expect wetter than normal conditions. And with that, today's presentation was recorded and past presentations are also recorded. Here are all sorts of web links that you can get tons of information, a lot of the information that I showed you within this presentation. I thank you all for your attendance, and I thank Doug and Dennis for being great helps in getting this together. Here's our contact information.
Hey, thanks, Justin. That was great. Quite a few quite a few questions. I think a lot of them we've answered for the most part. Let's see. I wanted to bring up a couple things really quickly, and maybe Dennis, you'll want to chime in on this, or Justin. You mentioned the fact that it's been relatively dry this fall, and there are a number of questions in here about that. And this is a tough question, I admit, but there are questions like how much does it matter, basically, that we're below normal in terms of precipitation for lots of things, agriculture, ecosystems, water supply, et cetera, from September, October, and November. How much is that really going to matter next year? Now, some people know the answer to this, I'm sure, out there, and they're like, a lot. But why does that matter?
I mean, it depends on where you are, or it depends on what your audience is, right? If you're a farmer, and you're going into the growing season with drier than normal subsoil profiles, you don't have a lot to work with. Also, livestock, uh, drilling wells, trying to find water. Perpetuating dryness will have impacts not only seasonally, but I mean, if we get stuck in a pattern, just for example, Iowa 2018 was the third wettest fall, 2019 12th wettest fall. Now we're drier than normal. So again, it depends on your audience, but there are impacts hydrologically in terms of drought, but also agriculture where I have a pretty big concentration. Dennis can add more on this one.
Go, Dennis.
Yeah, the other thing is the severity of the dryness. If you have some moderately dry soils, you want to be aware of it. It's not a huge issue. Some of the data we've seen out of Northwest Iowa, where someone actually did sampling, and in the 5-foot profile, they had 2 to 3 inches of water in that profile, where you would expect to have, where you would 10 to 12 is a full profile. That's a lot that they are in deficit right now. So those kinds of areas we have to be really cognizant of. Otherwise, Justin did a good job of covering the issues.
And it takes a sort of a sustained effort on the part of the climate to recharge low soil moisture, especially in lower parts of the profile, if you will. And maybe one of you can speak to across the entire region. We were so wet in 18 and mostly in 19. Maybe you can talk a little bit about all of that stored moisture and how that might have helped get us through this year where it turned dry, and how that bodes for next year. I think we're touching on it as we go through this.
Yeah, I'll take a crack at it first, Dennis. But yes, that's an excellent point. We had near record subsoil moisture across a majority of the upper Midwest and the central region. Specifically, if we look at Iowa, we had 95th to 99th percentile. So going back to that sponge is soaked. We had an excellent planting window in mid-April into May, and then we started going dry. That subsoil moisture was able to tide us over given the lack of precipitation that we started to see accumulate across Nebraska into Iowa, even into northern Missouri and Kansas. So we had a bank of moisture that we had available given the lack of precipitation. Once we started to expend that, once we started to go through the physiological processes of the row crops using that subsoil moisture, that's when drought formation started to occur. So those are the things that we have to think about both in the short term, but looking out seasonally as well.
Okay. Hey, could you back up one slide, please? I had a request to look at some of the information on the last slide. Now I'm going to go through the questions and such. I guess I had one other comment. It was the Cameron Peak and East Troublesome fires that were over 150,000 acres. The Pine Gulch set the record earlier in the year in Colorado, and then 2 other fires continued to break the record in terms of area covered in Colorado. Anyway, that was a small point.
My apologies to our Colorado folks.
I just want to get that right so Becky would be happy with us.
Yes.
Is snow counted as precipitation and precipitation ranks that you showed earlier? Yes, it is. I think I answered that one. Normally, winter season is dry. That is correct. Are dry conditions a concern if the ground is frozen? And Dennis, do you want you answered that? Do you want to just say what you said real quick?
Right. If you have dry soils when if and when we turn cold, that allows the frost depth to penetrate deeper. If we have a persistent period of cold, you can get the frost depth penetrating to where we can do damage to infrastructure, water lines, sewer lines, whatever. I think we saw this back in 2014 where we had dry soils. But you need persistent cold and you need the soils to stay dry. So those are the main issues.
Okay. And we've already talked a little bit enough about, I think, dry soils and spring planting in 2021. Regarding windy conditions, saw some comments about, record strong wind events in 2020. That may be, and we can have these individual days like we've had here in Kansas City and across the area yesterday and early today in terms of 40 and 50 mile an hour winds. But when you average it all out, You know, there is a web page we can actually go look at, and Justin showed us some of those some of that information about how windy or not windy it was. So people always tend to think it's windier than it. You know, the average over a month, for example, seems much windier if you have a couple really windy days. But if you have a bunch of calm days, it sort of balances itself out. So anyway, but I don't know the answer in terms of peak wind events, like I think you're talking about, Bryce. Have there been any adverse impacts to winter wheat due to the dryness, and how is the snow cover? Well, there is no snow cover, and yes, there have been some in both Colorado and Kansas, at least. Dennis, do you want to, or Justin, do you want to say any more about that? Winter wheat.
Yeah, Justin, you showed the winter wheat conditions, right?
Yeah. Let me see.
Yeah. I didn't see the number this week, but as of last week, winter wheat conditions were the third worst since 2000 over the last 20 years for this time of year. This week's numbers were probably something similar to that. Yeah.
A couple questions about, or a question about, does there exist a database for record-setting weather conditions, record-setting consequences of anomalous weather and climate and morbidity and all those costs and things? There is. I've listed a couple of them to get you started. There is actually a storm database that the Weather Service keeps, and you can probably type in into Google National Storm Database, right? Yeah, something like that into Google, and you'll find that. That's all the weather-related issues. And there's probably even more information. There's people in the Weather Service who can probably fill you in on that. If you have a specific question, Michael, feel free to write me an email. I will get it to the right person, and we'll get you an answer that you want on that, if the pages I gave you are not sufficient. Wild swings in temperatures influenced by anthropogenic climate change. A couple things on that is swings in temperature, especially in October, March. We call those the shoulder seasons, switching from cold to warm, warm to cold. We get crazy temperature flips, especially as you go west in this region, in the high plains and places like that. There are, if you're up against the mountains, we can get 50 and 60 and even more in a 24-hour period degree changes. What I will say about temperature records, though, is that we have seen a increase in the number of warm records compared to the number of cold records that we set, we'll say, on an annual basis. So, and that has been going on at least for the last couple of decades. Dennis or Justin, will La Niña impact spring season planting?
Depends on where you are.
Yeah, depends on where you are. So yes and no. It could, if you're going to, in areas that are dry and predicted to get drier, that doesn't bode well. And that, if you maybe go back a couple slides to your March, April, May seasonal, and that's a typical pattern for La Niña, where we see dryness starting to edge up into the central part of the U.S. If that happens, that's not a good thing necessarily. Let's see, what else? And wet, of course, to the east is pretty common during La Niña, and east being Ohio Valley, Great Lakes. Go ahead.
The one caveat you throw in is, one, does La Niña behave itself and act like we're expecting it to? That's not a guarantee. Likely, but it's not a guarantee. Yeah. Right. So, and you know, will La Niña affect spring planting? Yes. Do we know how much? That's a tough call. So yeah. It will affect it somewhat, but it may not affect it that much. So,
yeah, in terms of getting the seed in the ground, that's a shorter term question than we can probably answer. But if you pushed us on it, you know, we look at this map and we would say, well, you know, some of what we just said. Knowing what we know now on the ground and what could happen in the spring, or what's supposed to happen in the spring according to the outlooks, yeah, there could be some difficulties. Let's see, increases in chances of below normal temperatures throughout the winter. Okay, with drought spreading across the region, does that increase chances of below and or above normal temperatures for the winter. And I'll simply say, golly, I'm not sure, but generally with drier conditions, you don't get as cold. But I don't know, Dennis, Justin, what do you want to say about that?
Well, I mean, especially those cold air outbreaks in wintertime, those are kind of modulated by another oscillation called the Arctic oscillation, which is on a multi-week cycle, negative versus positive phase. That gets into way too technical terms here. But those outbreaks are difficult to see more than a few weeks out. And I don't know if that answered the question, but
yeah. No, I think that's right.
The other thing it doesn't address is what is snowpack. What happens with snowpack?
Yeah.
Right.
Because obviously we don't get much snow. That keeps it from getting as cold and allows you to warm up a little bit more. But we need to watch what happens with snowpack in the plains, particularly.
Right. And Dennis, do you want to say anything about the 98, 99, and 99, 2000 winters across pretty much the entire region? And La Niña,
they didn't
strong La Niña years.
They didn't behave themselves compared to other La Niñas. I don't know of any details specifically why. They just didn't.
Justin, can you point at those 2 years up there at the top of your screen? They were extremely warm years
right.
For our winter. We didn't have it was pretty mild winter, to be honest.
Yep.
And they were kind of the opposite of what we expected. So
and then
that can happen.
That gets into the phase of the Madden-Julian oscillation, and there are all kinds of caveats here that are built into why La Niña and to some extent El Nino don't always act as they should.
Right. Well, let's just remember, either El Nino or La Niña, they are adjustments to the whole climate pattern. They're not the climate pattern. So they are pushing 10 to 20% of what will happen, if you will. And that's a guess off the hip. There are 20 other pieces to the puzzle that influence what happens on a daily, weekly, monthly basis, seasonal basis for that matter, which all can come into play. But from a forecasting point of view, and what we see often from these things, and you can look at this map right here, these maps right here, and kind of see, a lot of cold up there in the northern part of the U.S. Usually, not always. Interesting, right?
Yep.
By the way, I'm looking down here in the lower right. I see 2011, 2012, and we know what happened that.
Mm-hmm.
Not to use that as an analog, because we don't do that. But just saying, there's another example of a warm, relatively dry. I don't know if it was dry actually. A warm winter season. Okay. By the way, this is only December through December, January, February. It doesn't take into account March, April, May, or anything else. I think that's it in terms of questions. Believe it or not, we had a number of people actually listen to us at the end here. So thank you very much for that attention. Thank you very much, Justin and Dennis, for your participation, and everybody else on the call. If you have any questions or comments, feel free to send it to us anytime. We're here. We'll be back in December, what was it, 17th?
Yes.
Yeah, December 17th with Beth Hall from Indiana to give us another presentation. So thanks, everyone. Have a great day. Have a great Thanksgiving, and be safe out there. Thank you.